Hello everyone. Okay, this particular video is on exponential functions. So you see we give you pictures of different ones, and so I'm just going to go ahead and get started. Excuse me. So um, those of you who saw the notes, you already know what this is about, so this is just kind of help those who maybe were absent and didn't see it. All right, so this is what we're going to be working on. You're going to be able to determine domain and range for any given graph, find f of x if I give you x in the domain, and recognize an exponential function. So next slide. Okay, so basically this is reviewing domain and range. If you remember from middle school, Algebra 1 previously, domain is defined as the input of a function or your x values. If you remember from middle school, you remember that whole input-output table machine thing. That's what this is about. So domain is what goes in. So by that reasoning, range is the output or what comes out. And so it's the output for your function, and it is your y values. And so what you see is you see a graph. So your growth period, end of your growth period would be domain, and your baby's length in inches would be your range. Okay? So moving on. Okay, so then we talked about this in class where we're going to give you examples of different graphs and you're going to identify the domain and range. Now, a couple people focused just on the points, and so they said the domain was these specific numbers. But there's a line going through it, and I'm assuming the line goes on forever. So when you look at this, your domain would be all real numbers because you can pick any x, and your range would be um, all real numbers because you can pick any y. Okay, so moving on to the next one. Okay, now when you look at this one, we actually did this when we did our unit on quadratics. So here, if you look at your domain, it's all real numbers because you're going to put any x. But if you look at range, it's only values y is greater than or equal to -9. So anything below this graph is not included in your range, okay? And so they give you that function, and that should look familiar because we did that. Now this one's a different type of curve, and so your domain is going to be all real numbers because you see it's increasing going that way, and it's also decreasing going this way. And then, so we're using all of our x values. And then our range, it's going up and going down. So again, I think all real numbers on both of those, okay? Now, when you look at this one, while our domain is all real numbers, our range is from y is, okay, how I want to phrase this. I don't have my slate pad, so I'm having to walk you through it verbally. So this would be -1 is less than or equal to y, which is less than or equal to +1. So basically your range is all the numbers in between -1 and +1, and it includes -1 and +1. Okay? Now here, when you look at your domain, you're looking at all real numbers, but when you look at range, it's y is greater than 0. Okay, so it's this and goes all the way up. Notice there's nothing below because it's not going to cross the y-axis, and we'll talk about that more later. Okay, now you look at this one. This actually was really easy. Most people got this just really easy. So what you want to do here is, you did this probably in Algebra 1. It's evaluating functions. So what you're going to do is, if f of x, which we also use as y, equals x plus 4, you're going to find f of -3. So what you're going to do here, is you're going to replace x with -3. So -3 plus 4 is a +1. So f of -3 is 1. Here you're going to do the same thing, replacing x with 2. So -4 times 2 is a -8. -8 minus 2 is a -10. So f of 2 is -10. Okay? Now, when we did this in class, from there you should be able to do all of these. The only hint I would give you is when you are squaring a term, anytime this number is negative, this x is negative, you should put it in parentheses before you square it. Otherwise, it's going to come up negative instead of positive, and it should be positive. Okay? And so we actually went over this in class, but that's all you're doing. You're replacing the x's with whatever numbers in the parentheses. Okay? And then here, just going over information about exponential functions. So I'm just going to walk you through it and just uncover these. So An exponential function is a function of the form y equals b raised to the x power, where b is a positive constant called the base, and it's not equal to 1. Your exponential functions are always strictly increasing or strictly decreasing. You're going to see more of that later. Exponential functions have a horizontal asymptote, and if you don't know what that means, that is an imaginary line that a graph approaches but never touches. We saw that in that previous one where the line was sloping down toward the x-axis but not actually crossing it. Okay? And so then here what we're looking at is examples of exponential functions. So if you look at the top, all of these are examples of exponential functions. These would not. This is a quadratic. Here, remember, b can't be equal to 1, so this is a no. This one, b has to be greater than 0, so that negative 1 makes it a no. And then here, it's got to be a constant or a number. X is not a constant, so that's why that would work. So the top row is the examples of, yes, this is a function, or exponential function, and the bottom row is an example of, no, it's not. Okay? And literally, that's it on this one. So we'll see you on the next video.